Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Hook. This one small slip cost students 3 marks on last year's paper. A length given as 3.4 centimetres was used as if it were exactly 3.4 centimetres. That tiny assumption lost full marks for many, and yet there is a simple rule that would have saved them. Stay with me for the next 10 minutes and you'll know it too.
First, what do we actually mean by bounds? Put simply, bounds are the smallest and largest possible values a rounded measurement could represent. They're not guesses, they're strict ranges. If a length is written as 3.4 centimetres to 1 decimal place, the true length could be anything from 3.35 centimetres up to, but not including, 3.45 centimetres.
Let's cover 3 common rounding styles and their bounds so you've got them fixed in your mind. 1. Decimal rounding to 1 or more decimal places. If a value is 2.7 to 1 dp, the lower bound is 2.65 and the upper bound is 2.75, with the upper bound usually written as 2.75 not inclusive. Practically, we write 2.65 less than or equal to x less than 2.75 to be precise.
2. Significant figures. Suppose a length is 3 significant figures, like 4.32. The bounds depend on which place is the last significant figure. For 4.32 to 3SF, the lower bound is 4.315 and the upper bound is 4.325, so 4.315 is less than or equal to x less than 4.325.
3. Whole number rounding. If a value is given as 7 metres to the nearest metre, the bounds are 6.5 less than or equal to x less than or equal to 7.5. That one is often used in area or volume questions, where measurements are whole numbers. Why do bounds matter? Because examiners want to see that you understand uncertainty. When a question gives rounded values, the marks are often awarded for correct intervals and correct propagation of those intervals through calculations, even if your final rounded answer looks different from the examiner's. That's where method marks come in.
Now, let's get practical. If you're asked for the lower and upper bounds of a calculation, like length times width, you should calculate the smallest possible area and the largest possible area by using the lower or upper extremes appropriately. For multiplication, you take smallest equals lower length times lower width, largest equals upper length times upper width. Important note. Do not mix exact values and rounded bounds without stating where the rounding occurred. If one measurement is exact and the other is rounded, make that explicit in your working. Examiners can award method marks for correctly set up intervals even if you forget to state units at the end.
Exam technique. The marks. Here's how marks are typically split on bounds questions. Example, a question asks for upper and lower bounds of an area. M1, correct setup of each bound as an interval. M1, correct method when combining intervals, for example using extremes correctly for multiplication. A1, a correct numerical interval, or a justified rounded approximation inside that interval.
So, if you show both interval definitions and your method for getting the smallest and largest values, you can often pick up M1 and M1, even if your final rounding is slightly different. In other words, write the method, not just the answer. The examiner wants to see your method.
Sort mistakes I've seen in recent papers. Students quote only the rounded figures as exact. They forget to use strict inequality on upper bounds, or they swap upper and lower values when multiplying. These are cheap marks to lose, and cheap marks to win if you follow one habit.
Quick win. A 3-step routine you can use every time. Step 1. Identify where the question says a value is rounded or to a certain precision. Write that on your paper next to the number.
Step 2. Explicitly write the bounds. For example, 3.35 less than or equal to L less than or equal to 3.45. Step 3. Propagate using extremes. For multiplication, use lower times lower and upper times upper. For addition, use lower plus lower and upper plus upper. And here's a 10-second sanity check. Substitute one extreme back into the original context to see if the result is reasonable.
Do this every time, and you'll stop losing marks to preventable slips. Write it down, don't just think it. The examiner can only award marks for what you show.
Before we finish, a worked example to bring this to life. Problem. A rectangle has length 3.4 meters, correct to 1 decimal place, and width 2.1 meters, correct to 1 decimal place. Find the bounds for the area. Step 1. Write the bounds. Length 3.35 less than or equal to L less than or equal to 3.45. Width 2.05 less than or equal to W less than or equal to 2.15. Step 2. Smallest possible area equals lower L times lower W equals 3.35 times 2.05. Step 3. Largest possible area equals upper L times upper W equals 3.45 times 2.15. Calculate 3.35 multiplied by 2.05 equals 6.8675 and 3.45 multiplied by 2.15 equals 7.4175. So the bounds for the area are 6.8675 less than or equal to A less than 7.4175 meters squared. On an exam, you'd box that interval, and then, if asked for a rounded final answer, give a justified rounding. For example, A equals 7.12 meters squared is inside the interval, so you can show the interval and then give the rounded value as an approximation.
Marking notes. M1 for writing the two intervals correctly, M1 for using extremes in the multiplication, A1 for the interval, or an acceptable rounded approximation with justification. If you only wrote 3.4 times 2.1 equals 7.14 without intervals, you'd likely lose the M1 marks. That's the difference.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Stay curious, and until next time, trust the process and nail that exam.